In the aim constraint section, there's one point I want to bring up separately to make sure we're all aware of it. And that is when we're using the object up method, we must never freeze transformations on the up reference object. So let's first do this the correct way. Let's look at our up reference object. It's moved up by 8 units. So when we zero out its values, it goes back to the origin. Okay, so with it like this, let's make an aim constraint between these two. Here, we're using object up with the name we just had. Alright, next, let's duplicate both of these. We'll add a suffix. This way we know this is the object we're going to freeze transformations on. Okay, so this has 8 units of translation. Let's freeze its transformations. And now we'll use our driver object again to aim constrain this new coordinate system model. And for this, we'll use the reference object we just created that has its transformations frozen. At first glance, there's no difference in the behavior. But when we move our driver object upwards, we can see a difference in the behavior between them. We know we're using the object up mode here. This means our up vector's direction is the direction from the driven object to the reference object's position. So let's take a look. Clearly, this object that's tilted, its rotation is wrong. We can also see here, from the suffix we added to the name, this is the object after we froze its transformations. So why does this happen? It's because when Maya calculates this aim constraint, for this up reference object attribute, it doesn't account for the frozen transformation scenario. It simply uses a matrix composed of the translate, rotate, and scale attributes to calculate its result. This kind of situation actually happens quite often in Maya. This is also a very important reason why, when we talk about controllers later, we never freeze transformations on the controller itself. So generally, in this situation, if we don't want our reference object to have values on it, what should we do? We should first move it back to the origin. Then we give it a group. Then we move the group 8 units. This way, we know through the parent relationship, our translation is relative to the parent object, and our child object hasn't moved at all relative to our parent. So here, the up reference object itself has no translation values. All the values have been given to its parent level. If we do it this way, when the aim constraint calculates, it can calculate it correctly. But if we freeze its transformations, it will produce some of these unexpected weird effects. So we all must pay close attention to this situation.